The first thing to recognize in this problem is that the information they are giving you, what does it mean in the context of the quadratic setting? So in this case, we're told that the diver reaches a maximum height of 20 meters above the water after 1 second. So basically what that means is that, and we're also told the diver started on a cliff 15 meters above sea level. So if we're putting time along the x-axis and the diver's height along the y-axis, the diver started at a height of 15 and then got up to a height of 20 after 1 second and then started to come down. So here we would have that this would be the point 120, and that would represent the vertex. The point 015 then would represent the y-intercept. We don't know what this point is, but that point would represent the time along the x-axis. The x value would represent how long it took the diver to get to the water. Okay, so the general equation of the vertex form is y is equal to a times x minus the x value of the vertex squared plus the y value of the vertex. Okay, so we know everything we need to know for the full equation except for the value of a. And so what we do then is we plug in the other point that we have in addition to the 1 comma 20. And so we set y equal to 15, and this is from the y-intercept, equals a times 0 minus 1 squared plus 20. So that gives us 15 equals a times 1, or just a, because negative 1 squared is 1, plus 20. And so that gives us that negative 5 is equal to a. And so that gives us our full equation for this situation. Negative 5 times x minus 1 squared plus 20. So in other words, at any point we can say that the height of the diver off the water, y, is equal to the time minus 1 squared multiplied by negative 5, and then with 20 added to that. So then to figure out the equation in standard form, it just means multiplying this equation out. So what we have to do is we have to multiply out the x minus 1. If you're very confident with your multiplication of two binomials, then do it in your head. But I think that would be a mistake because it's way too easy to get it wrong. So we have x squared minus x plus 1. And so our equation now becomes negative 5 times x squared minus 2x plus 1 plus 20. So we've replaced the x minus 1 squared with x squared minus 2x plus 1. When we then distribute the negative 5, we get negative 5x squared. And be careful here, negative 5 times negative 2x gives us a positive 10x, and then a negative 5, and we still have the positive 20. So that gives us a final equation when everything is combined of y is equal to negative 5x squared plus 10x plus 15. Okay, a couple error checks here. The 15 here should match the 15 that we already knew was the position of the diver at time equals 0. That's the y value of the y-intercept. We also know that this middle coefficient here indicates that the diver left the board with a positive velocity, which meant that the diver was heading upward. If this was a negative value here, that would mean the diver actually went downward without going upward first. And again, the negative 5 means that the force of gravity, in this case represented by this negative 5, is pulling the diver back to Earth. Okay, so, and obviously that applies to these situations where we're talking about something being shot or thrown up into the air. Okay, so then the next thing we're asked to do is find the equation in factored form. So when factoring, first step always is to factor out anything that is common to all of the terms in our equation. So again, we have negative 5x squared plus 10x plus 15, 10x plus 15. And so all of these can be divided by negative 5. And so we're going to end up with negative 5 times x squared minus 2x minus 3. So be careful about the signs here when you factor out a negative value. Okay, so then we're looking for two numbers that multiply to -2 and add up to -3. And so that's going to give us -3 and 1. So what we end up with is in our factorization is -5 times x minus 3 times x plus 1 as a factorization. When we multiply this out, we get back up to the standard form that we found in the previous question. Okay, so use the factored form to calculate when the diver will reach the water. So because we know that y is equal to -5 times x minus 3 times x plus 1, what this is asking is what value of x will give us a y value of 0. So we will replace the y value with 0 and then use the equation to figure out what values of x will make that equation true. And so because we have it in factored form, we can immediately see that the two values of x that will make this expression equal to 0 are x is equal to 3 and x is equal to -1. And so we discard the x is equal to -1 because it has no meaning in the physical interpretation of this problem. And so we end up with x is equal to 3 as the time when the diver will hit the water. And again, going back up to our graph, x is equal to 3, that makes kind of rough physical sense given our very rough graph here. So then moving on to the last question on this page, where we're asked to use the quadratic formula to confirm our answer for part D. That is relying on the fact that when we have ax squared plus bx plus c equals 0, then the solution to that is going to be given as x is equal to -b plus or minus the square root of b squared minus 4ac over 2a, again, just the quadratic formula. So substituting in our values for a, b, and c, we're going to get that x is equal to -b, which is -10, plus or minus the square root of 10, but we're going to put that in parentheses, and it's a good practice because when that value is negative, you want to avoid making the error, which I've seen too frequently, of squaring a negative number and getting a negative value. This value will always be positive because whatever you square, positive or negative, is going to be positive. And then minus 4 times our a value, which is -5, times our c value, which is 15. And all of that is divided by 2 times -5, which is our a value. Okay, so that's going to give us that we have x is going to be equal to -10 plus or minus the square root of 100. And then because we have a -4 and a -5, that's going to give us negative times a negative or positive 20 and then times 15. So we end up with a plus 300 under here, all over 2 times -5 or -10. So that's going to end up giving us that x is equal to -10 plus or minus the square root of 100 plus 300, which is 400. Again, all over -10. And that's going to be equal to -10 plus or minus 20, because 400 is a perfect square, over -10. And that's going to give us a value of -30 over -10 and positive 10 over -10, which gives us the two x values of x is equal to -3, or, sorry, positive 3, or x is equal to -1. So again, the two values that we got from above, and this is the only one that actually makes sense in the context of this problem. Okay, going on to the next page. Here we are asked to convert the f of x equals 3x squared minus 12x plus 20 from its current form, standard form, into vertex form. There are several ways to do this, but the one that I wanted to go over with you was where we figure out the x value of the vertex by using the fact that the x value of the vertex is -b over 2a, which means that it's equal to negative of -12 over 2 times 3, which gives us 12 over 6, which is equal to 2. When we plug in the y that in to get the y value, we're going to get 3 times 2 squared minus 12 times 2 plus 20 is going to give us 3 times 2 squared is 3 times 4, or 12, minus 12 times 2, minus 24, plus 20 is going to give us a positive 8. So that means that the vertex is equal to 2, 8. The vertex form then is going to be A, which we already know to be 3 from the standard form, 3 times x minus 2 squared plus 8. Again, x minus the x value of the vertex, that quantity squared, plus the y value of the vertex. We're also asked for the y-intercept, which, going back to the original standard form, we know the y value of the intercept has to be 20. And that means that our y-intercept is going to be equal to 0, which is always the x value for the y-intercept, and 20. Okay, the next thing we're asked to do is to factor this 3x squared minus 13x plus 12. So the first thing we do is we look to see, are there any common factors for 3x squared, negative 13x, and 12? The answer is no. They do not all contain x terms in their, they do not contain an x in their terms, only the first two do. And then we also know that 3, negative 13, and 12 do not share a common factor other than 1. So the method we're going to use is where we set up this table and we immediately put in the 3x squared and the positive 12 into these two positions here. We're then going to look for the two values that multiply to 36 and add up to negative 13. And the reason that we want them to multiply to negative 36 is that's what we get when we multiply 3 times 12. That's what we want them to multiply to. What we want them to add to then is negative 12, which is just the coefficient, negative 13, which is just the coefficient of the x term here. So those two values are negative 9 and negative 4. They have to be the same sign because they're multiplying to a positive number, and since they're adding to a negative number, they both have to be negative. So then we put those in here multiplied by x. So we have negative 9x, negative 4x. We then fill out the four values on the column edge and the row edge here at the top and on the left by finding the greatest common factor of each row and each column, but taking the sign of the value closest. So looking at the column, we have 3x squared and 4x, so the greatest common factor there is x. The greatest common factor of negative 9 and 12 is 3. We want the sign to be negative because the 9 is negative. For 3x squared and negative 9, we want to have the greatest common factor as 3x. Again, the sign is positive because the 3 in the closer term, 3x squared, is positive. And then down here we have negative 4x plus 12, so we have negative 4 as the greatest common factor. So our factorization is x minus 3 and 3x minus 4. And the x value of the vertex, as we did above, is going to be negative b, so negative of negative 13 over 2a, 2 times 3. That's going to give us positive 13 over 6 is the x value of the vertex. The x-intercepts then are going to be the values that make either this first factor 0 or the second factor 0, because basically what we're looking to do for the x-intercepts is solving this equation here. And the first solution then is going to be x is equal to 3. And the second solution will be whatever value of x makes this equation true. 3x minus 4 equals 0, which gives us that 3x is equal to 4. So x would be equal to 4/3. And so our two x-intercepts then are 3, 0, and 4/3, 0. Okay, factor each of the following fully. Well, for this first one here, again, we look, are there any common factors? The answer is no. The answer is yes. So we factor the x out, leaving us with 2x squared plus x minus 15. And the process we're going to use is the same as we used above. So we're going to create the table here, and we're going to have 2x squared, and we're going to have negative 15. And so we want two numbers that multiply, for the same reasons as above, to negative 30, and add up to positive 1. So those two values are going to be 6 and negative 5, which when we put into the table here, we can put 6x and negative 5x. By the way, it does not matter whether I put the 6x in its current position here or whether I had switched them and put the 6x down here and the negative 5x up here. So then finding the common factor. So the common factor for 2x squared and negative 5x is x. The common factor for positive 6 and negative 15 is positive 3. The greatest common factor for 2x squared and 6x is 2x. And the greatest common factor for negative 5x and negative 15 is negative 5. So that gives us our factorization of x plus 3 times 2x minus 5. And we have to remember that we had factored out an x up here, and so that has to be part of our final factorization. Otherwise, if we'd left out the x, our factorization would not have multiplied back up to our original quadratic there. Okay, next one. Okay, first thing is to note that this thing has 4 terms, so that means it's different from sort of what we've seen previously here. So again, the first thing we look for, are there any common factors that we can factor out of 2x cubed, 5x squared, negative 6x, negative 15? The answer is no. They do not all contain an x, and the 2, the 5, the negative 6, and the negative 15 do not all have a common factor. So what we do now is we factor by grouping. And so we look at the first 2, and we look at the last 2. So 2x squared plus 5x squared have a common factor, which is x squared. So we factor that out, and what's left for inside the parentheses here is 2x plus 5. Then we have a negative 6x and a negative 15. And so because the sign of this negative 6 is negative, we're going to have minus. And then we're going to look for the greatest common factor of negative 6x and negative 15, which is going to be, and again, because we want a negative value, it's going to be negative 3. So we have minus 3 times 2x plus 5. What you'll notice now is that we have 2 terms, both of which have a factor of 2x plus 5. So now as a second step, we're going to factor out that 2x plus 5 from both of these terms. So we have 2x plus 5, which we'll put in parentheses. Now what's left, when we factored the 2x plus 5 out of this first term here, what's left is x squared. When we factored it out of the second term here, what was left was negative 3. And so now we have the complete factorization of our original quadratic, and we can see that if we multiply this back out, x squared minus 3 and 2x plus 5, we end up with 2x cubed minus 6x plus 5x squared minus 15. So we have our 2x cubed plus 5x squared minus 6x minus 15, our original quadratic. So this is the factorization. You'll notice that x squared minus 3 cannot be further factored, but you have to be on the lookout for the possibility that, let's say, instead of x squared minus 3, you'd ended up with x squared minus 9, let's say. Then this is factorable because you have the difference of perfect squares of x minus 3 times x plus 3. And again, you can think of this as x squared plus 0x minus 9, which means that we need two numbers that multiply to multiply to -9 and add to 0, so those numbers would be 3 and -3, which is how we got this factorization here. But again, in the problem that you have on this sheet, we did not have that situation because this term here, x squared minus 3, is not the difference of perfect squares because 3 is not a perfect square.